The second question says, two boys are standing at the ends A and B of a ground where AB is equal to small letter A. The boy at B starts running in a direction perpendicular to AB with velocity v1. The boy at A starts running simultaneously with velocity v and catches the other boy in time t, where t is. We need to find the time at which the boy starting from A would catch the boy starting from B. It is given that the boy starting from B would travel in a direction that is perpendicular to side AB with a velocity v1. So this here would mark his velocity vector. And if he is allowed to move for a time t, he would reach somewhere here. And this length that he would cover, or the distance that he would cover, will be equal to v1 times t. The velocity multiplied with the time given will give you the distance covered. Now, if the boy starting from A should catch the boy starting from B, he would travel in a direction that is heading to that particular point, because they are starting at the same point of time. They are starting simultaneously. So with the same given time, if the boy starting from A should catch the boy starting from B, he should travel in a direction that heads to where the boy starting from B would be at a given time t. So this here would be the velocity vector v vector of the boy starting from A. And given a time t, he would cover a distance vt to reach the point where the boy starting from B would have reached. Now, from this figure, this question is easily solvable. That is because what we need to find out is an expression for t. You know that this triangle here that I've marked now, this little triangle here, is a right angle triangle, and you can see that the hypotenuse has a value vt, and one of the sides would have a value v1t, this side here, and the other side, the base, has a value a. In that case, we can write an expression which connects these three terms, and that will be hypotenuse square, that is vt square, will be equal to side square plus side square, that is a square plus again v1t whole square. Now, on expanding it, I'll have v square t square will be equal to a square plus v1 square t square. Please keep in mind that what we need here is an expression for t. So if I rearrange this expression, I'll have v square t square minus v1 square t square is equal to a square. And if I take t square in common, I'll have t square taken out, v square minus v1 square is equal to a square. And that would mean t square is equal to a square divided by v square minus v1 square, and that implies t is equal to root of a square divided by v square minus v1 square. And from the options, the correct option is option B, which says t is equal to root of a square divided by v square minus v1 square. That's how we solve it. It's very simple. We just have to list out the data that is given in the question on a figure, and that would help us to understand how we can write out an equation which connects all these parameters, and we solve that equation, we get to the answer.